Greetings, my name is Cameron Shane.
I'm Amelia Benow.
And I'm Ethan Penarski.
We are presenting on the press release and associated scientific paper for the Cow AT 2020 MRF.
Let's discuss the initial event that sparked the need for a new class of supernova. In 2018, a supernova occurred which brightened more rapidly than usual and was 10 times more luminous than regular supernovae. Referred to by the random sequence of letters assigned to the flash, AT 2018 Cow was so unique it necessitated its own subclassification. It was immediately clear to scientists, such as Anna Ho from Caltech, that the physics and driving mechanism of such an event were abnormal and in need of further investigation.
Before we dive into the article and paper, some context is called for. A cow is an immensely bright supernova that lasts for a relatively long time. They radiate in multiple parts of the EM spectrum and are found primarily via the superluminous X-rays they give off. Cows form from massive stars in dwarf galaxies, and this most recent cow further confirms the original hypothesis that these are fueled by accreting supermassive black holes, or magnetars, which are neutron stars with outstanding magnetic fields. All cows are considered fast blue optical transients, which are quick pulses of energy due to a massive star death. They're blue, have a fairly rapid rise in intensity, and reach their maximum intensity in around a week, declining back to undetectability in around a month or so. Cows last for much longer than that. They are a recent discovery dating back to 2018, and they have an awesome name. These cow events are named as such after the first of their kind was randomly assigned the name AT 2018 Cow. The spotlighted cow is AT 2020 MRF, which was discovered on June 12th of 2020 and classified as a Type 2 supernova, which is characterized by rapid collapse and violent explosion.
The article, which focuses on MRF, was written by Liz Cruchy and published to sciencenews.org on January 22, 2022. The article answers the basic questions of who, what, where, why, and when of MRF, all while comparing it to the original cow. The press release elaborates on the theories behind the cow's engines, or in other terms, what fuels them. Key concepts in astrophysical terminology were replaced by attention-grabbing descriptions that were easier to understand for a general audience. On the left, the images of MRF were taken using the X-ray Spectrum Röntgen Gamma Space Telescope. The images were taken 6 months apart and reveal the blooming cow in the center of the frame. This graphic was not included in the original paper, but was in the article.
Looking at the paper in comparison, one can quickly make out what is being left out for comprehension's sake, for better or worse. Among many things, the paper by Dr. Yao's team describes the rationale for the conclusion that cows come from massive star deaths, this being because they form in low-mass, star-forming galaxies. It provides more detail about the X-ray events, such as how they are comparable to long-lasting gamma rays. It explains what led to the candidates for the engine, that being due to the observed soft X-ray variability, soft X-rays being ones with low photon energies, and it conveys the oddness of these theoretical engines. For example, a magnetar is supposed to spin once per 1 to 10 seconds, and be slower on average than normal neutron stars. A cow-forming magnetar would spin once every millisecond.
The paper shows how MRF compares to other cows in regards to its luminosity over time and its measured wavelengths. It also compares the optical spectrum of all cows to a perfect black body.
Overall, the press release does a great job of keeping things simple, exciting, and accurate. Nothing it says is untruthful or inaccurate. To a non-scientist, this article would serve as a good summary of the cow-like event. For those who are interested, it links the original scientific paper. However, to the scientist, it leaves something to be desired. It glazes over key astrophysical phenomena that make it scientifically significant, such as the mechanics of the supernova's high-density driving mechanism. It also barely touches on the original cow and why this more recent event is important. AT 2020 MRF's X-ray emissions can be used to uncover its driving mechanism better than previous cow-like events. It also completely lacks any graphics from the original paper and is so short it leaves out a plethora of interesting details from the paper.
In summary, the news article does an okay job at explaining the paper. The vague language and rushed descriptions leave the reader with a surface-level understanding of the cow-like events. The article maintained focus and didn't exaggerate the key topics. For brevity's sake, much of the nitty-gritty in the paper was left out of the article. We collectively give this article a rating of 3.5 out of 5, not enough cows.